Hi, this video is on combining like terms. This is the first part of 3 actually. There's going to be 3 different parts to this, just because combining like terms is the make or break. Combining like terms uses everything that you've used in combining like terms. Combining like terms uses everything you learned in algebraic properties. Also, it is used in solving equations, which we've been doing the past 2 chapters. So this chapter, this unit 3, is going to be like the culmination of like all of those different methods that we've been using, all put into one. And also some of the things that I've been teaching you, I'm actually going to give you a reason why they work the way they work. So here are some things. First off, like terms, and this are going to be the first thing we're going to talk about. And I'll just slide this on over. So go and pause or whatever. Like terms. Terms that can be grouped together because they have the same variables raised to the same power. So there's a lot to take in on that. They have to have the same variable. You can't add x and y. I know a lot of people say you can't add apples and oranges. Yeah, you can, they're fruit. Great, which I think is a funny joke. But you can't combine x and y because x might equal 5 and y might equal -2. Well, 5 plus -2 is going to be 3, but you can't say they're the same because they are different. One's positive, one's negative. You can't combine x and y like that. And everything at the very last few words, raised to the same power. X can be added to x. However, x cannot be added to x squared. We're going to go more into that later in the examples. And it says the same variable, but that's not also the case. They might not have any variable. 5 plus 2 is 7. That doesn't change. And they don't have variables on them. What about those? Well, if it doesn't have a variable attached to it, that is called a constant. 2, 3, whatever. We'll talk more about that in a few minutes. Coefficients are the numbers in front of the variable, and then there's the variables themselves. So we're going to just get right in. We're just going to talk about this one real quick. If I was to give constants a color, let's say I'm going to do all constants green. Well, a constant is a number, like I said, with no variable. Well, that means 5 is a constant. It doesn't have an x, like these do, and it doesn't have a y. It's completely by itself. So it's a constant. Like variables, the variables that are the same, here's x, and here's x. So those are both the same. Y is an entity all on itself. So y is a separate color. I want to just use a purple color for that. And there's y. So those are the variables. Now the numbers in front of them are called the coefficients. And this is pretty big. Here's 7. Here's -3. That's -3. That's not just 3, because remember, if we add the opposite, that's -3, technically, not 3. And then of course there's 2 right there in front of that x. So all of those would be the coefficients. Those 3 things is what this unit is what this next 3 videos are about. So let's jump right into it. Example number 1. I would like you to simplify, move this on down, simplify 7x plus 2x. There are 2 methods for it for tonight. First one would be the triples method. Triples again is, well, and by the way, triples I think is a huge method for this one. I'm going to assign a color for the x's and a different color for y if I had another variable. But this time I only have this one. So I've got blue and blue. They're both x. So I'm going to use that for that. And by the way, it's going to get even more interesting. I'm going to use open dots for positive x. Again, when we get to negatives, we'll do that in a minute. We got 1, 2, 3, 4. Sorry, 1, 2, 3, 4, 5, 6, 7. Those are all good x's. 1, 2. So if I put these together, I draw my dotted line. I'm sorry, I'm going to press the whole thing. If I draw my dotted line, I would rearrange. Now I have 1, 2, 3, 4, 5, 6, 7, 8, 9. And since they're all positive, I'll darken this up for you. And since they're all positive, I know it is positive 9x. Okay, so that's using the triple method. Now, tonight I'm calling it anti-distributing. Next video, the rest of the videos I call it factoring, because factoring is a huge thing you do in Algebra 1. And that's actually what I call anti-distributing is actually what factoring really is. So here we go. Anti-distributing. If I have 7x plus 2x, I'm going to first rewrite. You know what? I'm going to do this a little differently than that. Here's what I'm going to do. Here we go. I'm going to rewrite. So I'm going to take 7x plus 2x. I'll put my equal sign right here. So I'm going to rewrite. That's my first step. 7x plus 2x. Okay? Now here's my anti-distributing. They both have x. We'll get into rearranging in the next problem. I'm going to draw my balance line, line up these equals. I'm going to take x, and I'm going to put a set of parentheses. Now remember, anti-distributing. Distributing is you go from parentheses and break out of the parentheses. Anti-distributing is grouping things together inside of a parenthesis and having a variable stand outside waving. These both have x, so x will stand outside. 7 and 2 will go inside 7 plus 2. And then 7 plus 2, of course, is 9x. You might say to yourself, Mr. V, can't I just go 7 plus 2 is 9? I'm okay with that eventually. Later in the chapter, I will be okay with that, just skipping this middle step. However, for now, I want to see this, and I'm going to call this factoring. Okay, and then we added. Okay, and then that's my final answer. 9x is my final answer. So that's my first step. So two variables that are both the same, easy enough. Let's go on to another one. Example number 2. Okay, again, I have 7x plus 5 minus 3y plus 2x. Now, remember, this is the one I had up here earlier. I'm just going to underline all the x's in blue. I want to underline this one in red because it's y, not because it's evil, just because it's y. I'll put plus negative. And then I'm going to use green. Sounds exciting, right? Okay, now here's where the triples pay off, I think. 7x. Take my blue, 7 open circles. 1, 2, 3, 4, 5, 6, 7. Because those are good triples, I'm keeping them open. Then I have 1, 2, 3, 4, 5. Good constant triples because they're positive, keeping them open. -3. I changed that into that minus -3, and I'm gonna rewrite the original one right here. That minus is a little deceiving because then you just think, oh, it's +3. No, 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 it's -3. So I'm going to take my red for my y, and I'm going to use closed circles for evil. Evil triples, evil. And then 2 more positive x's. 1, 2. I'm going to draw a dotted line, and I'm going to rearrange. I'm going to put all my positive blues together. By the way, what do you put first? Do you put y first or x first or the constants first? Here's how I think about it. Elmo says ABC. So, like, right? Think about it. Alphabet. Go A, B, C. X goes first. 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are all my x's. Cross these out. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to take my y next, not the green, the y, because y goes before. Constants go in the very back. Constants are always in the back. 1, 2, 3. And if I had to cancel stuff out, I would. And then my 5 greens. 1, 2, 3, 4. Oh, they're supposed to be open, sorry. 1, 2, 3, 4, 5. Let's just take it as it is. 7 positives, 7, the blue was x, plus negative, but really you're not going to put plus negative. You're going to definitely put minus 3y. By the way, that's 9x, not 7x. Plus, because these are all positive, 5. That's it. So we have 9x minus 3y plus 5. And that's it. Let's go with the anti-distributing. Start with my original problem. 7x plus 5 minus 3y plus 2x. I'm going to rewrite 7x plus 5 plus negative. I'm going to add the opposite, 3y plus 2x. Now comes my next step, and I've got this written down below in my tool bag. This is it. Actually, I'll give that to you in a minute. Next, because of the commutative property of addition, I can rearrange all of these. That's where this starts to become amazing. I can start moving stuff around because they're all addition signs. So powerful. I'm going to put an balance sign, of course. I'm going to put all the x's in the front, 7x, done, plus 2x, done, plus negative 3y. The negative stays with the 3y, plus 5. And I'm going to put commutative property of addition. CA, commutative property addition. Now I'm going to anti-distribute or factor, calling it factoring. 7 plus 2x. This doesn't have anybody to dance with. This doesn't have anybody to dance with. So I factored the front part to combine them. Because 7 plus 2 is 9 plus negative 3y. Oh, don't forget that x. Don't you dare forget that x. That almost did. Plus 5. So I combined. Now, this is my last step. I call it cleanup. You're not going to see plus negative on a test. You're going to see it as 9x minus 3y plus 5. And I do that at the very end. So again, both answers, 9x minus 3y. I really love the triples because I am a visual person and I love to see the pictures and totally clicks. If you're all about the steps, you're all about the steps. During class, I am going to be asking you to do both methods at least once, just so you can get used to both of them. Okay? Example number 3, last example. Example number 3 says simplify 6 times the sum of y plus 8, 6 times the sum of y and 8 minus 5y. Okay. Now we start to get into it. Here we go. I'm going to choose my color for positive y is open circles. And the rest of those are just constants. Now, I'm actually not going to underline the 6 because it's on the outside. Let's just go back to our distributing lab. In our distributing lab, I made you draw the triples or the algebra tiles. I made you draw them 6 groups of, remember when we multiply, 6 groups of y plus 8. I'm going to do that. I'm going to choose another color. Choose purple for y. No, I'm choosing red for y. Right. So we got y, and then we got 8. 1, 2, 3, 4, 5, 6, 7, 8. Times 6 means I'm going to do this 6 times. 1, 2, 3, 4, 5, 6. So I already got 1, 2, 3, 4, 5, 6. All the green. 1, 2, 3, 4. Here we go. Yes, I am going to draw 6 times 5. 8 is all 48 of them. And yes, they are getting closer and closer together. But you get the idea. I've got my 6 rows, even though they're all over the place, of those, of constants. And then, at the very end, after doing all of that for just this, it looks like a Christmassy. After that, I've got minus 5y. But because it's minus, we know it's negative. So I'm just going to use 1, 2, 3, 4, 5. So think about it like, think of it like the solid dots and then the open dots. I can just put that into there and it's gone. Like evil triple, good triple. Poof, gone. So really, watch. 1, 2, 3, 4, 5. So, what do we got left? We've got 1y, and I don't put a 1 in front of y. You can, but I'll do that right now. But usually you don't leave it like that. 1, 2, 3, 6 times 8 is 48. And that's all that's left. I would write it as y plus 48, not 1y. But that would be our final answer. Okay, using properties. And I'm going to zoom out a little bit so you can see what I've got over here. I've got a little bit of a checklist, and I highly recommend keep writing this down on every piece of paper that you do for the chapter 3 or unit 3. We're always going to rewrite. The first step, if you noticed, I distributed. I would rearrange. I would combine with cancels, and I would clean it up. So going back over here, using properties, here we go. I'm going to start 6y plus 8 minus 5y equals. Okay? First step, rewrite. And you know me, I like my plus negative 5y. Just how I am. Heck, you can even put it in parentheses so it looks a little better. Bala, I know. Shakala. Step 2. I'm going to distribute. Okay, let's distribute. 6 times y plus 6 times 8. I'm actually writing it out. I am writing 6 times y plus 6 times 8. I am not writing 6y plus 48. No. I want to see it written like this. This part just comes down. And notice, he didn't get a 6. He's not inside the parentheses. He's not with the group that gets a 6. Oh man, I'm out there by myself without a 6. Bummer. 6 times y is 6y. Plus 48 plus negative 5y. So that's my distribute. That's all distributing. Next, I'm going to rearrange. Oh, balance line. I'm going to rearrange 6y plus variables in the front, constant in the back. Negative 5y plus 48. And I'm not gonna get too crazy if you can say 6 minus 5, 6 plus negative 5 is 1. I'm not gonna write, I'll write 1 right now, but again, I'm not gonna get in the habit of doing that. 1y, so they both got a y. Y doesn't vanish. Plus 48. The answer is not 49y. Not 49y. It is equal to y plus 48. Done. I cannot combine y and 48 together. It is y plus 48. That's all you can do. And that's it. 2 different methods. I'm always a stickler for the triples. You know me. So, that's it for today. This is the first part of the combining like terms. There's another one next time. See you later.